Anything. Oh, there it goes.
Hey there. Okay. Welcome, welcome, welcome. This is part of the J Champions Conference, as you all know. I'm Barry Bird, professor at Drew University in Madison, New Jersey, USA. The speaker for this session is Ian Darwin, and the topic of his talk is Flutter is the new Java, or is it? Ian, go to it.
Thank you, sir. I think I have to improvise the audio for this one. Singing's not my forte. So enough of the silliness. We're here to talk about Flutter. And Flutter is the new Java, or is it? Now this building, I put in Java into the clip art, and it came back with this building, which at first looked like a Starbucks, but I think it's actually, if you look really closely, it's actually a truck terminal. And I'm going to put that on full screen. And it's actually a truck terminal. So we're not doing too well with the clip art, but hopefully we'll do better with the technical side of things. We, as developers, find ourselves afloat and aflutter in a sea of new devices. With Android, there are, who knows, hundreds or maybe thousands or maybe even more of different devices out there. With iOS, they come out with new iPhone versions every, I don't know how often, a couple of times a year maybe. We have people who want to use web browsers. We have people that want Windows or Mac desktop apps. We have other people who want Chromebook apps, and who knows what else they're going to need next year or the year after. So to avoid being adrift in that sea of many devices, we need to be able to write once and run everywhere. Who cares? Why? Well, first off, there's the cost of development, and there's a time to market. If you have a big budget, you can hire several teams to build different versions of the app at the same time. If you're a really small shop, you have to write one and then the other, and that's going to slow you down. So either way, you're wasting a lot of time or money, and in some cases both, trying to get your app out there so that people can actually use it. So cross-platform is pretty much vital these days. Although if you look in the ads, you still find people saying we need one Android developer and one iOS developer. So those people need to be on this talk and learn how to do it once, right once. Of course, the challenge is, how do we know which cross-platform tools to use? Because everybody will tell you that their way is better. And they're probably right from a certain point of view. But which one is better overall? Well, you're going to have to do a comparison yourself. I'm not here today to tell you that absolutely everybody should use Flutter for everything, because there are a number of good solutions out there. I'm focusing on Flutter because it's the one I am using, and I think it's a really good one. I will not go so far as to say it's the best one. So we do have to pick one, and I picked Flutter, of course. The of course is the part that matters. Flutter has some advantages and some disadvantages. Well, what's good about it? It's open source, and I'll say more about that at the end. It's designed to make building beautiful apps easy, and to make apps that can run fast enough for modern 60 to 90 frame per second scrolling and video updates, which is a challenge for some of the other cross-platform tools to do. It's got, I wouldn't say the full weight, it's got quite a bit of the weight of Google behind it. So it's likely to be here for a while. And it is open source. So even if Google said, oh, we're tired of this, we're going to do something different, you could still use it. People would still be maintaining it and putting releases out and so on. It does support a wide range of platforms. And I'll cover the platforms in a minute. Again, I just want to caution you that there is no one-size-fits-all solution. Anybody who says that their one way of doing it is the only way is, well, don't listen to them. Just run away fast. A bit of history on how we got here and where we're going. Starting with, well, I'm only casting my net as far back as 1995. Java goes online promising Wara. Wara is write once, run anywhere. And Hot Java was a mobile browser written completely in Java. This was a big deal in 95. It was a not only a web browser written entirely in a really high level language, but it was also there to promote the Java language. And applets, which was the web technology, was one of the first in-browser animation techniques to be able to actually run programs in the browser and display the results. Finally, it also promised to be able to run everywhere. How? Well, there are two solutions. One of them is the portable documented class file format. Your program a.java is going to produce a .class file, a.class, that's going to be the same whether you build it on Windows or Mac or Linux or some other platform. It's always going to be the same. And it's also a big win for tool makers, people who make development environments and compilers and so on, because everybody was free to make their own Java tooling, even compilers, even development environments that did compilation for you from the specification. Anybody could use it as long as they were keeping to the published specification. No incompatible changes allowed to the language or to the standard Java packages. Second aspect was of the run anywhere was that they would provide Java runtimes for all major platforms. So in 1995, they came out with platforms for, let's see, Windows 95, OS 2, if you remember that, anybody remembers that, Solaris, which was Sun's Unix platform, Macintosh, and a couple of others, I can't remember exactly. Linux support came along later, and the source code for the entire runtime was published so that people could make it work on other platforms. And the specification for it was also published along with the language, but the specification of how the VM was supposed to work so that people could build their own implementations of it as well. Well, of course, they needed a graphical system, graphical window system, GUI. So the first version of that was AWT, the Abstract Windowing Toolkit, that came out with Java classes for things like labels and buttons and push buttons and scroll bars and so on. These were mapped directly to the native components, which was great for the Mac users because they were very adamant that things had to look and feel quite right on their platform. The downside was that it provided, it inherited bugs. Some of the different platforms had different bug sets in them. And secondly, they had to have a lowest common denominator so that if platform A didn't include feature B, they couldn't include feature B on any other platform as well. So it was kind of restrictive in that sense. However, AWT existed for Windows, OS 2, Mac, Unix Motif, and maybe a couple of others at the time. Well, after a while, the limitations of AWT got too constraining. So they came out with Swing User Interface or Swing Toolkit. And this was actually much nicer. It was implemented entirely in Java and only used the AWT toolkit to get connection to the Windows system and to do basic draw functions. Everything else is done in Java, which is a pretty impressive bit of programming. If you have a standard JDK, you have a swingset2.jar file. You can run it just by saying java-jar, find out where it is and give that path. And you see along the top, there are icons for the various sections of the user interface. And there are within each of those, there's examples. And they all include the source code so that this was designed not only to show off the toolkit, but to help people get started building with it. So it's a big success and a big win for Java developers. But not for mobile. Why? Well, AWT didn't work, and Swing had too much overhead for the mobile devices of the day. BlackBerry, you remember them, they made smartphones. They went with Java Micro Edition, which was really scaled back and designed for very, it's sort of a contradiction term, but for dumb smartphones, for very early smartphones. And so BlackBerry spent hundreds of developer years, literally, adding stuff onto it to make it usable to build a modern smartphone platform. Very impressive piece of engineering that unfortunately all went to waste when they switched away from it and went to version 10 of their operating system. They threw it all out and started it all over. Anyway, around the same time, a tiny little company called Android Incorporated started out, and they took a different route. They built their own user interface completely in Java, but optimized for mobile platforms. And that turned out to be successful. Google bought them out, as you know, and went with it and became really successful. After they got successful, Oracle went for the cash grab and sued them over the fact that they had the temerity to re-implement some of the public interfaces of Java, even though Sun, a company that Oracle owned, Sun Microsystems, Sun invented Java and Oracle bought them out. So then, despite the fact that Sun had published the specification for the VM and for the language and said, you can implement this, and Oracle initially said, gee, we love this competition. And actually, Larry Ellison was on stage at Java 1 saying, we love this competition, we welcome Google aboard. They later chose to sue them over implementing these public specification interfaces. So that's potential there for great harm to the software industry as a whole. You can probably imagine that. Anyway, a bit off topic, but it's relevant to being mobile. The other key thing that was introduced early on was the Hotspot VM. And that was added to the JDK in order to speed things up, because initially the first couple of releases of Java were considered to be too slow, partly because computers in that 25 years ago were slow, but also because it could be improved. So what the Hotspot VM does, if you're not familiar with it, is it takes one method at a time and compiles it from Java class code into machine code for whatever CPU it happens to be running on, Intel or ARM or whatever. And therefore, it's much faster. And it actually does quite a great deal of bookkeeping. It says, this method here has been called so many times, it's very popular. I better recompile it again with a higher level of optimization. So they really work hard to make things run quickly in Hotspot. So it's a big win for performance. Well, after AWT and Swing, the next official toolkit was Java FX. And this was originally called F3 and then Java FX scripting, and now it's just called Java FX. It was a project to build a better user interface for desktop applications. And at one point, it was supposed to replace Swing completely, but it never did and probably never will at this point. It was also, Java FX was also extended to mobile, which is interesting. And after that, Oracle dropped the mobile component of it from the distribution for reasons that I'm sure make sense to somebody in Oracle headquarters. They did open source all of it, I think all of it, almost all of it anyway. And a company called Gluon, G-L-U-O-N, their website is gluonhq.com, have released the mobile version of it now and claim that it can run on iOS, Android, desktop, and so on. So Java FX is, in a way, is one of the competitors to Flutter at this point. It has grown up into be a full-grown competitor. Of course, it's not the only one out there. There are many others because it's what everybody wants, is to be able to write once and run everywhere. So there's some web-based ones. PhoneGap, also called Cordova, is one of the earliest ones that's still around. React Native is one that gets a lot of attention. It uses JavaScript. It writes in JavaScript and then manages to compile it down to native code for the mobile platform. And is based on reactive programming, which is going to be the thing of the future. Xamarin was originally a separate company, an open source project, and a small company behind it. And they were bought out by Microsoft. And Microsoft continues to maintain it. It's now a part of the Visual Studio product line and runs on .NET. And you program that in C#, which is their Java-derived language. Well, I want to focus really on Flutter, of course, but these other things are worth keeping in the back of your mind because they all have, every one of them does certain things well. So I don't want to rule any of them out. But I want to focus on Flutter because that's the title of my talk. So Dart is the programming language that's used in Flutter. And Flutter is the SDK, the software development kit or toolkit that uses Dart to build portable applications. And Dart is a programming language that is somewhat like Java or C# or any of the related languages, but has a lot of annoying little differences, some of which are significant and some of which are just annoying. So I'm going to focus on that first and take a brief look at the Dart language, kind of oriented to coming from Java developers. But if you've used any of the other languages or even Python, you should be good with this stuff. This is the next few pages is a separate slide deck from a Flutter course that I'm developing. And these guys are not finished quality. So I'm sorry if there's any errors in the slides or anything, but it's still good enough to give you a good look at the language, I hope. So let me just switch out here. Someone in the chat mentioned SWT. I didn't include that. Sorry, I'll cover that questions at the end for the most part. So here we go. So Dart language, modern, concise, object-oriented, and functional language. Syntactically, it's in the brace structure family, where C, C++, Java, C#, and so on, they all borrow from the C language, which in turn borrowed from BCPL. Everybody borrows from somebody at some point. And some borrowing some other languages like Kotlin. We're going to cover a brief look at the major features of the language, assuming you've used one of these related languages. So concise syntax, like I said, type inference. Dry principle, meaning don't repeat yourself. That kind of goes with being concise, but not necessarily. It's multi-paradigm. You can write totally unstructured code. You can write object-oriented code. You can write functional code. We always start every discussion of programming languages with the Hello World program. So here is the Hello World program for Dart. It's just the word main, parentheses. No, we don't have to write out string args or just char star star argv. Just put nothing because you're not accepting any arguments. Open curly brace means begin. Print hello world, and the closed curly brace means we're done. And if you have your path set correctly, you can just say Dart hello.dart, and it'll compile it and run it for you, and we're done. So that's all you need for the Hello World program. The Hello World program idea, if you're not familiar with it, comes from, as far as I know, comes from Kernahan and Ritchie back in the 70s, who said this in a couple of their books, Kernahan and Plowger as well, that if you know how to type in a program into the computer, compile it, do any other processing like link edit in the old days, and run it and get output. And if you can do that in a Hello World program, by then you can do anything else. You can expand it from there to do anything else. So that's the historical origin of the Hello World program. So how do we organize programs? If you are using the normal way of doing things in Dart, which is a standalone program, has a bin folder for the main program and a lib folder for everything else. Well, that's kind of silly because there's always just one file in the bin. So the Flutter people ignored that slightly and keep the main in the live folder along with everything else. So that simplifies it. There's only one source folder. And there may be subdirectories under it if your program grows to, when your program grows to that point. Source files are named with the lowercase name with underscores convention. So we might have main.dart and new underscore course.dart. A new underscore course.dart would contain the source for class new course, which is written in the Java way with capital letters on the words, on word boundaries. It is obvious there that therefore that there is no requirement for source file and class name to be the same. You could call the file fred.dart and it would still have new course, class new course in it. It would all still work. The source file can have multiple classes in it, as shown here, where one refers to the other. Variables are named with lower camel case, just like in Java. For example, int my useful value begins with an m, small m, and has capital at word boundaries. In terms of visibility, what can one class see about another? There's almost no setter and getter methods in Dart because fields are public by default. And members, fields and methods are made private by putting a leading underscore in the name. They don't have to do any keywords. They just use the naming convention. Begins with an underscore. Oh, it's private. Doesn't, it's public. Very simple. So here's class X, which has some int, which is private because it has an underscore. Another int, which is not private, and because it doesn't have an underscore. And static has the same meaning as in Java. That is, there's only a single allocation, and it can be used without instantiating the class it's in. So that's just the same as Java. This is all pretty much the same as Java, except for the private keyword being replaced by an underscore. Getting stuff out, we have print. So yay, no more typing system.out every time you want to print something, right? Just type the word print and the stuff you want to print inside. Big win. Everything's an object, even integers and Booleans. So this is one difference from Java. Java has 8 built-in types, which are not objects. So people may successfully made the claim that Java is not a pure object-oriented language. Nobody cares, but because it's done for performance, it's done for a good reason. But these guys can say this is a pure language because integers and Booleans are objects. Same as in Python. We declare and initialize variables like in most languages. Int I equals 42, I equals 27. The variable I is updated to refer to a newly created int object with the value 27 inside it. There are some built-in types, bool, not Boolean, int, and string, and some of the other numeric types. Local variable type inference allows you to use var instead of having to type out the full type of something. You just say var x equals 42. It'll figure out that it's an int. Var y equals 42.0. It'll figure that y is a double. This is in Java nowadays for local variables as well. So this is becoming widely accessible. It's just annoying that you have to stop and think whether you're wanting to declare something as an int or a double when you're already typing an int or a double. So if you want if you wanted y to be a double, you could give the type explicitly, but you tend not to because it's just less typing. Only when you really need it. It would actually be easier just to type var x equals 42.0 if you wanted it to be floating point. Also, again, like in Python, lists and arrays there's only one type. There's not 2 separate types. Var age is equal square bracket 25, 31, 27 makes a list or an array with a length of 3. Map of people scores, Ian 25. So there's keys and values there separated by a colon. And that again, syntax is from Python, among other places. And if you want to give a more precise definition, you may use the same syntax as in Java, angle brackets and a type parameter, map from string to int. We don't have, because ints are objects, we don't have separate wrapper types like in Java. So we just say map from string to int, and this works for these values. So strings are entered with either quote, double quote, or single quote. So we have Ian entered in double quotes, Robin in single quotes, and so on. Print names dot length is going to print the number 3 because there's 3 elements in it. Print names dot runtime type, that's a built-in field, and it's going to print that it's a list. And one of the really cool things is string interpolation, where in a string, you can include variables values with a $sign. And that eliminates a great deal of complexity. No need for string builder, no need for string printf, because it's no need for string concatenation most of the time, because we just use interpolation. So if we have a var called hostname, which is a website, and a page on it, which is initially null, but might get set to some particular page later, we can then say, create a string with https:/$ $hostname. So that's going to take the value of hostname and interpolate it into the string here, /, and then $page. If $page has any characters in it, they'll be stuck in there as well. So that makes up the string URL already containing those values. So again, no need for printf, no need for string builder. Print URL. Now, we also said var, hostname, page, and x. Notice, by the way, you can mix in a var. You can mix strings with numeric types, and it'll still compile. It just does type inference on each one individually. So x is an int of type 40, a value 42. If we say print x is plus x, the Java way of doing things, that won't compile, because there is, unlike Java, there's no implicit toStringing. So x.toString here will work, but it's much easier just to use the Dart mindset way of doing things, which is to say x is $x. It's less typing, it's less error prone, and so just use it. That's all I can say. Dart has most of the common operators built in, less than the comparison operators, the arithmetic operators, the bitwise operators, the same as in Java and C in those languages, tilde and equals. Most of these can be by the way, here's something to be very careful of. When you're looking at other people's code, many of these operators can be overridden within a class. You can define a class that defines how addition works, for example, or multiplication. So you can, in fact, apply those operators to objects. There's about 50 reserved keywords, which I'm not going to go through all of them. There's notes underneath them, some that are built-in identifiers, some are keywords that are used for asynchronous work. That's equivalent of Java threads. And there's a few others that are just reserved and can't be used as identifiers. None of those should be used as identifiers. But so the majority are familiar. Abstract, try, catch, finally, do, while, for, and so on. True and false, they're all very similar, and null. Const versus final, this is an area that's different. C++ introduced the const keyword, and Java removed it and provided the final keyword instead with a slightly different meaning. Well, Dart allows both. Final means what it does in Java. That is, you can only assign to it once, and you must assign to it either with an initializer or in the constructor. And const means more like what it has in C++. That is, the state of the object has to be, not only the declaration, but the state has to be constant, and therefore must be known at compile time. So that's seems like a strange limitation, but you get used to it fairly quickly. Classes and interfaces are not distinct objects as they are in Java. Every class defines implicitly an interface with the same name. And so you can refer to a class either with implements or extends. And the semantics are slightly different, of course. Implements means that you are getting to implement all of the methods yourself, whereas extend has the same meaning in Java. That is, you can inherit class methods from the other class. But there's no separate keyword for creating an interface. And as in Java, you can implement multiple interfaces, as shown at the bottom here. Enums are pretty much like Java with one exception. There is a values method, but not a value of method. So here's something that won't work. We have an enum called ops unit. This is for an application a real application that I have, where we have different operations units within the corporation: North America, South America, Europe, and Asia Pacific. And we have somebody tried to define because there is no value of method, we defined a method called ops unit from string, which takes a string input and tries to find the corresponding ops unit enum constant and return it. Well, the thing is, it gets to the bottom, throws an unknown ops unit, and it shows the string, again, using string interpolation. The problem is it always throws the exception. So a bit of head scratching needed there. What's wrong with this picture? If you know Java really well, you probably guessed it already. One of two things. I'll give you a few seconds to mull it over. First off, return inside a closure, which is a closure is like a lambda in Java. This returns from the closure, and that's the same as in Java. So this return doesn't go down here and return this value. It simply returns from this little block of code here, which means it will go on to the next value. And it'll just keep doing that. And when it's done all of them, it'll get down here. The other one is, even if that weren't the problem, the enum toString return includes the class name. So it would return opsunit.na, and you're comparing that against just na. So yeah, here's a version that does work. We set found to be the value. And at the end, if we have found it, we return it. Otherwise, we throw. It's a bit more code, but it works. Tony Hoare invented the concept of null back in the late 50s, early 60s sometime. And he, years later, turned around and called it his $1 billion mistake, because of all the time wasted tracking down all those null pointer exceptions in Java and null pointers in C and equivalent all these other languages that support this. So he basically says, it seemed like a good idea at the time, but it was, in retrospect, a really bad idea. So Dart has a bunch of null aware operators. Double question mark is if null. Expression 1, double question mark. Expression 2 gives expression 1 if it's not null. It gives expression 2 if it is null. And similarly for the other 3 variants of it. They're also provide, speaking of the question mark operator, they also provide the ternary operator like in C and Java. X is a Boolean now, not a null. Not null or not null. And if it's true, this value is returned. If it's false, this value is returned. So those operators are all in Dart. Strong typing. So Java is strong typed. Dart is strong typed with a bit more flexibility. Like JavaScript and like Java 10, you can use var to avoid having to give the type. It figures it out. Once it's done that, it will use strong type checking. So if you try to assign a int to a string or vice versa, whether you declared them with their actual type or with the var, it still knows what their actual type is. So it'll still fail out on you at compile time. There is a kind of an escape, which is using the type dynamic, which is sort of like object in Java. It means there'll be something here, but we have no idea at this point what it's going to be. So we just declare it as dynamic. It's pretty much the equivalent of object. Coding conventions. Every language has certain stylistic coding conventions. If you're in Java, you know there's the Sun Java coding conventions from the 90s that people still use with a few modifications. The Dart people have their own, and it's at dartlang.org. One second here. So try it out. You may not like it, but it's been invented by the people who are experts and even by the people who invented the language. So you might as well follow it. Don't read it now, but it's there for you to look up. Packages. Packages are like libraries or like jar files, includes in Java. I'm not going to discuss them here because I have a slide on them in the back in the main slide deck. Pub.dev is really important. It lists a lot of third-party packages. So many of the ones that I listed in my dependencies list near the beginning are coming in from pub.dev. Be aware when you look at it, some of them are Dart only, some are Flutter only. And the Flutter ones will tell you which platforms they're good on. So this is the basics of Dart. There's much more to it. They have generators and iterators like Python, for example. There's a Dart language spec at the European Computer Manufacturers Association. Again, dart.dev. Here's a fun thing. If you want to explore Dart interactively, there's DartPad, which lets you type a few lines of Dart and see if they compile, and if they do, lets you run them, assuming you don't do anything too terrible to the operating system. So there's an exercise which we're not going to do. And now we go back into our regularly scheduled programming. So Flutter runs almost everywhere. We've talked about this briefly, but Android, of course, because Google invented it. iOS, because iPhone is the #2 platform. Mac OS desktop works. Windows desktop also works, but is in beta. So they urge people not to ship those applications yet. And web applications. You can build a downloadable web application, all from the same code base without in general having to write any platform dependent code, assuming that there's a hidden assumption there, of course, which is that the packages you want to use support the platform you want to run on. Most of them do, but there are some that haven't yet been expanded to run on, say, Windows or even Mac desktop. Pretty well all of them will run on Android and iOS, but even that's not 100%. Dev tools. So first off, before you can build to run on an actual device, you have to have that device's native toolkit. This is a bit of a limitation, but many of the cross-platform toolkits have the same limitation, so it's not too surprising. For Android, it means you have to have the Android SDK installed, and that's available for the major platforms. Now for iOS, if you want to make iPhone apps, you must have Xcode. And Apple has decided to make Xcode only available on Mac OS, which by extension implies that you can only build an iPhone app if you have a Mac. Well, not to be done, Windows is the same way. You need VS Studio, I think it's 2020. Read the install guide, not VS Code. You need the full version of it. And that only runs on Windows. So you are having to run on Windows. And for Linux, you need CLang and a few other smaller packages. So again, you can only build Linux applications on Linux. So you're going to wind up having a bunch of computers at your disposal to really take advantage of the cross-platform. And again, that's not specific to Flutter. Most of the other cross-platform things, I won't say they all are, but the majority of them are the same way. So looking at the different toolkits, Android Studio is the official and recommended IDE. It's free to download. It's based on IntelliJ IDEA, and it has actually dozens, 2 or 3 dozen now already, of third-party plugins to make your Flutter development easier or more fun or simpler or something. So feel free to explore that. Let's take a quick demo here using Android Studio. Now this is a demo application that I created just by saying new Flutter project and filling in the name and a few other bits and pieces. So it has only one source file in lib, main.dart, and it has a couple of classes. There's a stateless widget, which is what you need for that's effectively your main function is here, but it basically creates an instance of my app. Notice you don't need the new keyword here. You can just put the name of the class with parentheses. Again, it figures out that you mean to call the constructor, just like any other method. So we have our stateless widget, which is the basically the main program effectively. We have a stateful widget, which has a state class in it. And the state class is the interesting part of this application. It has a counter in it, a numeric counter starting off at 0. It has an increment counter button method that is called when you click the button. And it calls set state with, this is a closure, like a Lambda expression in Java, that gets invoked later on when the button is pressed. And then there's build, which I'll say more about in a few minutes. That's an interesting side diversion. So I'm going to look at the main widget here, which says set the title to Flutter demo, set the theme to have a primary swatch of green, the green color, and make the visual density adapt to the platform so that if you run on a small mobile device or a big screen 1920 by 1080, it'll still scale reasonably well for any of those. And that's all I'm going to say for now. I'm going to run the application now, so you'll see it running on my phone. Right now it's on the home page of the phone, and hopefully it will pop up in just a second. It says it's restarted the application. Maybe it's still running. Yes, there it is. So I don't know if you can see it, but it just has in the center, it has the, you have pressed the message, you have pressed the button, and then this many times, and then a number underneath it. So that if I press the button, that number should go from 9 to 10. Oh, because I restarted the application. So sorry, it's now back at 1, 2, 3, 4, 5. Now, interesting point is that I'm now going to change the color on in the code from green to red, or let's pick orange in code completion, OR, hit return, and nothing happens. But watch what happens when I type Control S to save the file. Immediately updates on the real device. That's one of the things that's really great about Flutter is the instant reload, instant hot load. It's way faster than most other applications, so-called instant reload, which actually takes a few seconds or a minute. This one is really instantaneous. The way it works is in debug mode, which you can only tell because there's a little red banner in the corner here that says, you probably can't even see it, it says debug, that red slat, hit away. it reloaded it because of Android's mechanism. It reloaded it and doesn't have the patch in it. So the patch is, thank you. The patch is in the virtual machine. That's how it gets it so fast, but it doesn't necessarily doesn't hold across application reloads. Normally, you'd be running in an emulator, and you wouldn't have this trouble. But the key thing I wanted to show was that when I just have to put this back up one more time, is that when I put the change to the color, I'll have to use a different one. Let's try blue. Notice what happens to the number. I'm now going to type Control S so it'll actually do it. And notice it changes to blue, but does not change the number. The number, the counter, that was the key part. The counter remains active. So it doesn't lose the whole application state. It only changes the little bit of code that you changed, and everything else stays the same. The only time this doesn't work is if you change some global state, like a field in the top level class. But most other times, this instant reload is really wonderful. And all you have to do is save. If you want to invoke it explicitly, there's the lightning bar button here will do it. But so there you have it. Okay, back into our slideshow. So that was talking about Eclipse. Sorry, that was talking about Android Studio. For Eclipse, Eclipse is a great IDE, and I like it, and I use it, and I've been my favorite IDE for many years. It's losing ground to IntelliJ IDEA because of the fact that Google switched Android Studio from Eclipse-based to IntelliJ-based. And so that's what we're using here. It sort of feels like a lost cause to do mobile development with Eclipse nowadays. So Eclipse Foundation has had trouble getting and maintaining developers for their mobile projects. So it's kind of a vicious cycle. Mainstream Java and other languages and Java Enterprise very much focused on Eclipse, but mobile, it's a real uphill battle for the Eclipse people to keep up on mobile. Microsoft Visual Studio, VS Code, they have plugins. You just have to go into the install extensions menu item and they'll be there for Flutter. When you in all of these IDEs, when you install, as far as I know, when you install the Flutter plugin, it also automatically installs the Dart plugin because one is a prerequisite for the other. One other thing, which I said I'd come back to, is that we don't have a separate language. For example, Android uses XML to lay out the components, and it keeps those in a different place. They're in a different folder. With Flutter, the layout is done by composition, by code composition. So I skipped over that code, and I don't want to go back to it right now, but everything is done by creating objects and setting attributes on them. So it's all done with Dart code. And when people first hear that, they seem a little bit leery, but after you get the hang of it, it really is convenient to have everything in one place. And that doesn't mean a violation of structure. You can still have model view controller or any of the patterns that split things up. But it's very convenient to have the widgets and the layout of them together. That's the part that it puts together. So I think they've done a good job of designing that part of it. So many libraries. I mentioned this briefly in the other slides. And they don't call them libraries. They even call them packages. But I just wanted to use library clip art. So that's why I called them libraries here and use that screenshot of the books. Here is the what I promised to give you, the dependencies list for my application. My instructor, I arrived at the course site, send an email type application that has all sorts of bells and whistles. It's from the day when, before the pandemic, when people actually used to travel. Remember that? Grandpa, did you used to travel back in the old days? Yes. Hopefully it won't be that long. So you would go to you're teaching a course, you would show up at the new course site and push a button and it would say, I'm here, so that the people at the head office could say, phew, Darwin made it again, through customs and through airports and everything. And it would generate a report and send it electronically back to the head office. So it has the ability to send email as an email sender built in. It has shared preferences to remember your settings. It has device info because there's still unfortunately one or two things I need to do slightly differently on Android and iOS. URL launcher for the help screen. Moor is a database thing that I'll talk about in a minute. And this is sqlite. sprintf. I said you don't need printf because of the string interpolation. So why do I have it in there? Well, the answer is this application is a conversion, a migration from a previous Android app where I needed to use printf. I have these big, complicated format strings, and I don't want to bother converting them all to string interpolation. So I just left them as they are and used this add-on library of sprintf. Intel, of course, is for internationalizing. Down at the bottom, we have Flutter WebView, Flutter HTML. There's a camera because if there's an issue at the course site, we want to be able to take a picture of it with the phone camera and add it to the email that gets sent. Path is like finding where stuff is, where files are. It's like the environment stuff in Android to say where's the download folder and the pictures folder and so on. It's the same kind of stuff. And add to calendar. When you first get assigned a course, you put it into the application, push a button, and it drops it into your device calendar so that it can show up in your desktop scheduling or your online web scheduling. So you don't have to re-enter stuff. You just put it in the app, push a button, and it's added to your calendar. So those are some of the packages that I use in this particular application. It's a real application that people are using. For database, I mentioned this briefly. SQLite is the same as SQLite in Android. It's not identical API, but it's at the same level of complexity. Moor is a implementation similar to, patterned loosely upon, let's put it that way, Room. So Moor is Room backwards. If you don't know about Room and you're using Android, you should, because it's way more convenient than using SQLite directly. It's a much higher level. It's an object relational mapping tool. And Moor is a fairly good implementation of it for Flutter. Design patterns. I'm not sure how many of you know about design patterns. Looking at the comments, I suspect most of you have at least a vague good idea of what these are. So I'm going to skip over saying too much about them. For those that don't, briefly, they are a standardized way of describing solutions to recurring problems in design of application. So actually, I'll just give this one example anyway, since there are probably a few of you that don't know. So they came into software architecture from building architecture, from the Faculty of Architecture at UC Berkeley. A guy named Chris Alexander was a professor there in the 70s, and he wrote a book on it. In a couple of decades later, in 95, a book called Design Patterns cataloged the 24 most important ones that applied to software. But in the original, they were for designing houses and offices and things like that. So, for example, there's a pattern called kitchen layout. So, show of hands, have you ever been in a kitchen? Probably yes. If so, you might have noticed something, which is that almost every kitchen you go in, the three main elements, which are the stove, the sink, and the fridge, are arranged in a geometric pattern, which is not a straight line, but the only other possibility with 3 points is a triangle. Now, sometimes it looks like this, and sometimes it looks like this, and sometimes it looks like this, but it's always a triangle. And within the triangle, The sink is usually placed near the window for two reasons. One is that washing food needs good light for food safety. And the other is that washing dishes is dreary and anything you can do to lighten it up. The stove is placed where you can put a fume hood to get the smoke and stuff to the outside quickly and easily. That might mean going through a roof or through a wall or whatever. And also, if it's a gas-powered stove, as it often is, you need to minimize the number of twists and turns because each one of those requires a pipe fitting joint, some of which will start to leak after about 20 years and cause houses to blow up. So by minimizing the number of those, you're contributing to the safety of people who live in the house 20 years later. The fridge is heavy. If you ever tried to move one, you'll know this. And so you want to put it where there's a floor joist so the floor doesn't sag. Those are what are called the variations and their consequences of that particular pattern. So that is design patterns in a nutshell, rather a long nutshell, I guess. So in mobile, well, in application in general, we have a variety of patterns with names like these. MVC, you're probably familiar with. It's the model view controller. It's the oldest one. It dates from the mid 1980s at Xerox PARC, Palo Alto Research Center, where a small gang of people who, by the way, invented almost everything, including object-oriented programming, laser printers, file edit view menus, graphics, a whole ball, desktop computers, laptop computers, tablets. The first tablet was called the Pad. Wonder where Steve Jobs got the name for his tablet. Anyway, so they invented MVC along with all that other stuff. Model view controller. The model is the data handling code. The view is what you see, and the controller is what reacts to what you do and mediates between the model and the view. Model view presenter is from Martin Fowler, a very famous object-oriented theoretician. Model view presenter. MVVM, model view model. It sounds redundant and somewhat is. The view model is a value adapter that lives between the model and the view. And there's a fourth part to MVVM, which doesn't show up in the name, unfortunately, called the binder, which is specifying how to synchronize the data from the view to the model and back. The binder can be written in code or it can be declarative in JSON or XML, depending on the implementation. MVVM tends to be was originated by Microsoft and tends to be used more on the .NET side of things. BLOC stands for Business Logic Components. They didn't want to call it BLC, so it sounds like a BLT when you say it out loud, and that makes people hungry. So they called it BLOC. The O is supposed to be not capitalized, but I got carried away with the capitalization. In BLOC, everything is stream-based, and this is similar to reactive programming or Java 8 streams, if you're familiar with those. Here's a quote from one of the two articles that I'll give you in a minute. The stream is like a future, but instead of returning a single value asynchronously, streams can yield multiple values over time. If a future is a value that will be provided eventually, a stream is a series of values that will be provided sporadically over time. And fortunately, the package Dart async, Dart::async, which is standard built-in package, so you don't need it in your imports, in your dependencies rather, has a stream controller class, which is very handy for building this. I'm not going to go too far into these design patterns, just to mention that BLOC is different in some ways than MVVM and from MVC. Here's a picture of the article whose URL is at the bottom for a to-do application written completely in Flutter. The UI obviously is the widgets where the graphical user interface lives. The BLOC code, the reactive class or classes that hold the stream of to-do items and handle state management for it. The repository is where we specify data operations. There's a DAO that implements those. which could be hard-coded, hand-coded rather, or it could be implemented using Moor or some other object relational mapping. And behind that, there's a local database. And if you want to be able to sync your to-do items with a remote service, then there would be a web service provider as well. So these two articles both are fairly good at describing the block pattern, and they will take an hour or two just to read through them. So I don't have time to really go into it in much more detail than I have so far. But hopefully that'll be enough to whet your interest. So far I've said a lot of good things about Flutter. Is there a dark side? Well, like duct tape, everything has a dark side. You just have to find it. Even if the thing that has the dark side is great or wonderful or the best ever, it's still going to have some limitations. So there's one subtle thing about Dart that will not affect most of you, but it is that Dart and Flutter both are open source projects that are totally administered by Google, and therefore they have the final say on what goes into it. So it's not the same as something like Linux, where people from all over can contribute, and if their code is good, it'll get accepted. Here, if the Dart or the Google people object to something, it won't go in. If you have any minority operating systems other than the big three, and you try to put a portability change into the repository, they will reject it. They only definitely insist that they will only support the big three platforms. So this annoys me personally because I run most of my stuff on a minority version of OpenBSD Unix, and they're never going to support it. So I have to keep a couple of other computers around for that purpose. You do have to learn the Dart language, obviously, and the Flutter API, and a little bit of YAML. YAML is the language that is used in the dependencies list that I showed you. And YAML, this is really curious. The make program, which was one of the original build tools written in the mid-1970s, was very finicky about spaces versus tabs. And that caused James Duncan Davidson to invent the Ant build tool for building the Tomcat web server on Java. This is all Java related. And he said, I can't remember whether to use spaces or tabs, so my only possible solution is to write my own tool from scratch, which he did, and it became successful. Ant, and that led to Maven and eventually Gradle. So it surprises me that YAML in this day and age is fussy about spacing, but it is. So is Python for that matter. What's the future? Put on my Yoda ears and say, always in motion, the future is. All I know is that it's growing and might run into growing pains. There is a Twitter account called Flutter Dev. And on there right now, there's a pinned post that says, 03/03/21. That would be this year, March 3rd. And join us for a special Flutter event. So I imagine they're going to announce a new release and that they're going to say that the Windows desktop build is out of beta and is ready for production. And that's all I'm going to guess at, because I generally haven't done a very good job of guessing what the future holds. But that one I think is a safe bet. And there'll no doubt be some other cool stuff. So I urge you, if you're at all interested in Flutter, mark that date and do check at Flutter Dev on Twitter and find out what they're coming up with, because it's probably going to be good stuff. So to wrap up, Flutter offers a solid path to cross-platform development. Single code base for all platforms. Portability handled. CPU portability handled by Dart, just like in Java, handled by the JIT, the compiler, and so on. And operating system portability handled by libraries. Oh, guess what? That's also the same as Java. Not the only cross-platform solution by any means. One of the best, in my opinion. Hopefully, I've convinced some of you that it's one of the best. I will leave you with this idea that how you could set about to evaluate Flutter for yourself. Download Android Studio or VS Code if you're a solid Microsoft shop. Build the sample applications that come with it, tweak them, break them, learn from them, find out what works and what doesn't. Build a simple application on your own. Try it on multiple platforms. Plug in an Android device, an iPhone. Try running the desktop applications as well. And when you get that far and you're happy with it, then start building your real application in Flutter. Some resources. Flutter.dev is the main page. Flutter.dev/community has some really good links on it. Books. There are lots of books out there. Be careful. Dart language books from before about 2016. Don't buy them. Don't get them. They made some significant changes to the language around that time frame. So anything that says Flutter and is relatively recent, like 2018 or later, you're probably pretty good. Medium.com/Flutter is another place for updates. And I have a couple of links on my own website on /Flutter. I have a resources page, which is not very comprehensive yet, but it's growing. And there is a chart of competing cross-platform development kits there as well. It's actually hosted on Google Docs, but you can just get to it from that link. So without further ado, the end. Thank you guys all for being here. I hope I've informed some of you and not irritated too many. And we have a little bit of time left, so I can switch this off. I can't see the comments page until I switch this off, so now I can take a look at it.
Have some questions for you. If you don't mind, let me just read you the questions that I collected during the talk. I'll turn off your screen for a minute. Mm-hmm. Can Flutter produce an app for Apple Watch?
Don't know. Good question. I will have to do some research on that.
Okay.
Probably, but I don't know for sure.
There was an early question on SWT, in your opinion. What was it in your comparison chart? We want to find out what you think about it.
Yeah, SWT is interesting. It is the standalone widget toolkit or the something widget toolkit. And it is written in combination of, I think, C and C++, if I remember correctly. I tried to port it one time and wound up abandoning that effort. For the main platforms, it is available, and it's what powers the Eclipse platform, which means that if you are moving Eclipse to a new platform, to a new operating system, you have to make SWT work before you can do anything. So yeah, it's an interesting choice. I wouldn't use it personally, but I don't want to say anything bad about it because it obviously works quite well for the Eclipse people. It's not a complete solution, right? It's just a UI toolkit for the most part. It has some extra stuff beyond that, but a lot of that.
It was an alternative to AWT.
Yes. Yes.
Yeah, good stuff. So if you're working on the web or the desktop in Flutter, apparently you can use only material design widgets. Is that the case? And if so, what do you do about that restriction?
I'm not sure if that's still true, but even so, the material widgets are pretty good, and I haven't found the need to go beyond them. If you wanted the Cupertino widgets on the desktop, I think somebody has to write some code for that behind the scenes for that to happen.
Okay. I've got a person who asked a question, wanted to confirm no primitive types in Dart?
Sorry, the question, no?
Yeah, it's a question that ends in a no primitive types? Really?
No primitive types. Yes, that is correct. Python has existed for many years without any primitive types. In Python, int and float and so on are all object types. And Python is very fast and does a very good job of garbage collection. The same is true with Dart.
And
It has almost no effect on the speed, and it makes it a pure object-oriented language, makes it a little more consistent in the rules for coding.
yeah, so the platforms that Flutter compiles to, Apple, iOS, Mac OS, Android, is it true that the rest, for instance, desktop, is really actually just a web app? Or is that not the case? Is it native?
For the web app, I think it's going to be JavaScript.
Right.
I haven't really explored it. For the desktop ones, I haven't looked inside it, so I'm not sure if it's actually. I've run the applications, and they seem to behave like they were coded, native code, compiled to native code. But I haven't decompiled them or looked at the behind the scenes stuff for them yet.
You mentioned early on that Flutter is growing rapidly. Do you have any stats on that? I'd be interested in hearing.
So would I.
Okay.
Everybody, like I said, everybody says their way is better, and everybody says their way is widely adopted. I don't have any real stats.
Yeah. Would you use Dart independently as a development language without using it for Flutter?
Would I use Dart independently? That's a hard call. I've been coding in Java so long that it's always my first instinct to write a piece of solid code is to use Java. Or if it's something simple, I'll use a scripting language like awk or Python, or even the Bourne shell. But I somehow just don't gravitate towards Dart automatically the way I do these other languages. Maybe I will with time.
Do you see Dart or Kotlin being the future languages for normal, quote unquote, normal developers? Or do you see
Yes.
Java still being?
That's a really hard call. Again, like I said, I've kind of given up on predicting the future. So I'm going to decline that question.
Oh, okay. Do you have any feelings about using Android Studio versus using IntelliJ IDEA to develop in Flutter? My guess is that IntelliJ has a few fewer features, but is a little bit more lightweight.
The Android Studio and the IntelliJ IDEA are exactly the same program with the same with the Dart and Flutter plugins added to one to make it look like the other. The branding is different, but it's the exact same program, so far as I know. Now that said, for IntelliJ IDEA, there is a community edition and a pro edition, and which obviously has more features. And I'm not familiar with what the extra features are that you get when you pay for the pro edition. The community edition is free, and that's the one that I think they're using in Android Studio.
Right. One of the things that I notice about Flutter is that community doesn't guarantee backward compatibility. So programs will break, can break. How do you feel about that? What do you do about it? What's the best approach? Is that what you'd consider a negative, or is it a positive in that it makes for development of better features?
It's like duct tape, a dark side and a light side. Java has gotten a fair bit of cruft built up over the years because of their guarantee of backwards compatibility, where other languages have tried to shed features that are no longer viable. On the other hand, you get into a situation like Python, where it took them a decade and a half to migrate from Python 2 to Python 3. And they eventually pulled the plug and said, as of, 14 days ago, totally no more support for Python 2 on New Year's, December 31st. So Yeah, you can't answer a question like that with anything.
Six of one, half a dozen of another.
Yeah. Mm-hmm.
Okay, very good. Well, thank you, Ian. To our listeners, I hope you enjoyed this session. I certainly did. Please have a great day and enjoy the rest of the Java Champions Conference.
Thank you. Thank you, everyone, for being here. Thank you, Barry, for moderating and keeping us on track here. And if you have any last-minute comments, you can put them in the chat. And otherwise, thank you again. My website was on the last slide, which I'm sharing, but he's turned it off.
Okay.
So
Ian Darwin. Search for Ian Darwin, and you'll find it.
yeah, that's true. There's only one of me, thankfully. One of me is quite enough. Again, thank you all.